Hi, welcome to our next lesson, which is Inscribed Angles and Polygons. The objective is how do we find measures of inscribed angles and angles of inscribed polygons? All right, you already heard about the word inscribed. So basically inscribed means inside a figure, something that is drawn inside a figure. But with angles, it's drawn inside the circle. So the inscribed angle have a vertex on the circle and the sides that are chords. So below we have a picture of an inscribed angle, ABC, and B is our vertex. And BC, also, as well as AB, are the chords. Those two chords intersect at the vertex B to create the inscribed angle. And inscribed angles have a relationship with the arc that is formed by it. So ADC is called the intercepted arc. Is a section of the circumference of a circle. So anytime you have an inscribed angle that is drawn inside a circle, the chords and the vertex create that arc, and it's called intercepted arc. So if an angle is inscribed in a circle, then the measure of the angle equals half the arc measure. And if the angle is inscribed in a circle, then the measure of the intercepted arc equals twice the angle. So let's say that we had ABC. We have angle ABC. Let's say it was 50. Okay, that 50 came out weird. Let me do that again. So let me undo, and then let's do that again. So this one is 50 degrees. So then that means the intercepted arc will be twice the measure. So then that will be 100 degrees. So I'll just put a dot there. So if it was vice versa, where I put 100 for the intercepted arc, then it would be half the angle would be half of that, and it would be 50. So that's what they're just saying. Inscribed angle will be half of what the intercepted arc, and vice versa. The arc is twice as much as the inscribed angle. All right, so we're going to do an example based on that. They said that if angle XWZ is 84, I'm going to use, so let's say, so this one is 84. They want to know what is the angle of XYZ. All right, so that XYZ is right here. Okay, so what do we know about that angle 84? We know it's formed at the center, and it goes to, and it creates an arc opposite of it. So that is the central angle. Remember, central angle is created, it starts at the center, and they have two radii that hits the circle, and that arc formed is the arc measure. The arc measure is equal to the central angle, so that part is 84. But notice that that arc XZ is also formed by that inscribed angle XYZ. So what we have learned about intercepted arc, the relationship between intercepted arc and inscribed angle, is that the intercepted arc is going to be twice as much as the inscribed angle. So that means we need to divide it by 2, 84 by 2, and then we get 48. So then that means XYZ, angle XYZ is going to be 48. Example 2, we have circle O. They say that AB is 70 and BC is 100. I'm going to use another color for that. BC is 100. And then they also said that arc AB and arc DC are congruent. So whatever arc I have for AB, DC is also going to be the same. And I'm just going to highlight them so that way I can distinguish between the arcs. All right, so now they want us to find the measure of all the angles in that circle. All right, so for angle 1, it's an inscribed angle, but we don't know what the intercepted arc is. But we can find it because we have AB, BC, and D and CD, but we don't have AB. We know that a circle is 360 degrees, so we can take all of that measure. So 70, I'm just going to put that 70 plus 100 to give us our measurement. And actually, I'm just going to put that in the calculator. I'm not going to put all that. So you know that you need to add all of that up and then subtract it by 360. And that will give us 120 for that part. And my 2 is weird. So 120. So then that means that arc is 120. So in order to find the inscribed angle, we need to do half of 120. So then half of 120 is going to give us 60. So if I can put it over here, so 120 divided by 2, that will give us 60. Angle 2, let's look at angle 2. That's formed by DBC. The intercepted arc is 70. So 70 divided by 2 gives us 35. And I'm going to show that, put that there. So 70 divided by 2. Let's look at angle 3. Angle 3 is formed by BDC. It's 100. So the inscribed arc has to be half of that. So 100 divided by 2 gives us 50. And if you look at angle 4, which is ACB, this arc is 70, so half of 70 gives us 35, just like angle 2. And then for the last angle, 5, angle 5 is formed by BAC. The arc is 100, so the half of that will give us our inscribed angle, which is, oops, let me press the wrong thing, which gives us 50. Alright, so we have all the angles based on the intercepted arc, and that's what it is. So intercepted arc, to find that, you do double the inscribed angle, and vice versa, you do half of that to find the inscribed angle if you have the intercepted arc. Okay, next one. So we have a first theorem that we're dealing with. We're going to look at the picture that is corresponding to that part. Is they consider AB, arc AB, which is in green, and list 2 inscribed angles that are intercepted by AB. So we're looking at the 2 angles that corresponds to that. So we have ADB, and then we have ACB. Okay, so those are our 2 angles, so we just have to write it. Those are the 2 angles that are dealing with that intercepted arc. If AB, arc AB, were 50, they want to know what would be the measure of the 2 angles that were listed above. So if the intercepted arc is 50, in order to find the inscribed angle, it would be half of that. So you would have to divide 2 to 50, and then you get 25 degrees. And that's it. Okay, so the summary for this type of situation, when you have 2 arcs, 2 angles sharing the same intercepted arc, states that angles that intercept the same arc are congruent. So those 2 angles that I marked, they are congruent to each other because they share the same intercepted arc. Alright, so let's look at the next picture below. They say consider congruent arcs FE and CD. And you know that they're congruent because of the little tick marks. They say list the inscribed angles intercepted by each arc. So I already drew the angle mark. So we have FAE and then we have CBD. CBD. They said that if FE and CD were equal to 30, which you can see, they're 2 arcs, what are the measures of the 2 angles you listed above? So again, you would have to in order to find the inscribed angle with their intercepted arc given, divide by 2, you get 15. So those 2 would be 15. So now what's the summary for this part, this type of situation? Angles that intercept congruent arcs are congruent. So that's all they're saying. If this part is congruent, that's congruent, then your angles are going to be congruent. Okay, let's go for the second theorem. Name the arc that intercepts ABC. So I'm going to highlight that. So we got angle ABC, and the arc interception, that's going to be arc ADC. And that's a symbol for arc. Is it a minor, major, or semicircle? Well, let's look at arc ADC. So notice that it creates this dome, and it's a half of the circle. So what do we call half a circle? Semicircle. What is the measurement for a semicircle? 180, because it's half the circle. Circle is 360, so half of that is 180. All right, so find ABC, angle ABC. Notice that that intercepted arc is formed by angle ABC. So then what would be the angle for that? Or would be the measurement, since we're looking for the inscribed angle? It would be half. So that means you would divide by 2, 80 by 180 by 2, and you get 90. So we have a right angle over there. So that's 90. So the summary for this theorem, based on what we just did, is that when a triangle is inscribed in a semicircle, it is a right triangle. Because half of 180 is 90, and 90 is a right angle, which is found in a right triangle. Okay, so let's do an example based on that. They have two triangles, ABD and ADE, that are inscribed in circle F. We have arc AB and arc DB that are congruent to each other. So I'm going to find a highlighter. Yep. So we have this, mark that, and then we have this, they're congruent. So that means angle 4 and angle 3 are also going to be congruent because they're formed by that intercepted arc. I'm just going to show them. All right, so now they want us to find all the measures of the angles in that circle, and they told us that angle 1 is 12x minus 8, and I'm going to put that in there. So 12x minus 8, and then angle 2 is 3x plus 8. All right, so first thing we need to do, we need to find out where to begin. We notice that there's a diameter AD. Diameter splits the circles into two equal parts, two semi-parts, so that's on 180 on each side. So if we look at the arc AED, which I will highlight in blue, it is formed by the angle ABD. So it's half a circle, it's going to be 180, and then the inscribed angle, which is B, is going to be half of that, so then we have 90 degrees. Okay, so in that triangle ABD, we know we have 90, so we know triangle is 180. If we subtracted that, we get 90, but we know that angle 3 and 4 are equal, so that means we divide by 2, and then both 3 and 4 will be 45, and I'll unveil that. 45 degrees for both of them. So I'll write that. Put that in green. 45 and 45. All right, so we got that. Now we need to find the other things. These two we can't do anything because we don't have the information. We only have this part that's 180, but that doesn't help us. But we know that this is half the circle, so the angle that is formed over here, which I'll put that in blue, is created by this intercepted arc. The arc is created by that angle. That green part, that whole arc is 180. So then that means this is going to be 90. So if this is a 90-degree angle, then these two, 1 and 2, will have to add up to 90. So we're going to do 12x plus minus 8 plus 3x plus 8 equals 90. We add up those two, that's going to give us 15x equals 90. The 8's cancel out each other. And then divide by 15, and then we get 6 as our answer for x. But we're not done yet. We have to plug it in. So for angle 1, we got 12 times 6 minus 8. Oops, that's supposed to be a subtraction sign. So 72 minus 8 gives us 64 for angle 1, and angle 2 we have 3x, so that's 3 times 6 plus 8. That's 18 plus 8, which gives us 26. And then we found both of our angles, 64 and 26. And again, it's everything you know about inscribed angles, intercepted arcs, circles, half a circle, the measurements, all that stuff. Okay, let's go on to our next one, our next theorem, which is 3, which states that if a quadrilateral is inscribed in a circle, then opposite angles, oh, that disappeared, opposite angles are supplementary. You know, supplementary means 180. So then that means A and C, opposite of each other, are going to be 180, and B and D, opposite of each other, are going to equal 180. So based on that information, let's do number 4. Quadrilateral ABCD is inscribed in circle P, and if angle B is equal to 80, and then angle C is equal to 40, let me put that in another color, 40, find angle A and angle D. So let's deal with angle A. Angle A is opposite C, so then it's supplementary, so that means we do 180 minus 40, which will give us 140 for angle A. And then for angle D, which is opposite B, we do 180 minus 80, which will give us 100 degrees, and that's for angle D. And that's it. Nothing to it. Opposite angles in a polygon inscribed in a circle, a quadrilateral, quadrilateral, four-sided shape, inscribed in a circle, their opposite angles are supplementary, which means they add up to 180. Right. So we've reached our end. Let's do a recap. We learned about inscribed angles. Inscribed they have a vertex that's sitting on the circle, and it's created by 2 chords. Those chords create the intercepted arc. The intercepted arc is going to be double of whatever the inscribed angle is. An inscribed angle is half of what the intercepted arc is. Okay, and also we know that angles that intercept the same arc are going to be congruent. Angles that intercept congruent arcs are congruent. And when a triangle is inscribed in a semicircle, which is 180, it's going to be a right triangle because you're doing half of that, half the intercepted arc to give you the inscribed angle, and it will be 90. And we also learned that if a quadrilateral is inscribed in a circle, then their opposite angles are supplementary. Supplementary means 180, so those 2 opposite angles has to add up to 180. All right. So if you have any questions about this lesson, feel free to email me and I'll help you out. And this ends our lesson. Have a good day.